All right, so I think we've got people here with us. So let's jump in as we have a lot to get through today. So big thank you to everyone for being here. For those that don't know me yet, I'm Amir Uki. I'm managing director here at BOI, where I lead our applied AI and technology practice. So BOI is a company we've worked with many enterprise teams across different industries, different sectors, different markets around the world. And most of them are probably doing exactly what a lot of you all may be doing, which is experimenting with AI, building really interesting prototypes and POCs, testing them, and now thinking about, okay, we have some success. How do we scale this into an enterprise capability? And what we've kind of consistently seen is that it does take a little more work to scale an AI capability than it does to build a POC. So today's session is going to be focused on the technical, the organizational, the strategic shifts that are needed to move from a POC to production and to turn AI from a kind of series of experiments into a much more durable long-term enterprise capability. So we will jump right in. And just to set the context a little bit, I would say that over the last 18 to 24 months, let's say, we've seen kind of this massive wave of AI experimentation. And what we're seeing now is this moment of reflection, as it were, where we're saying, okay, we've seen this be successful in the POC phase. Now we need to figure out, how does this scale? It's not just, can we build a model? Can we build an AI application? The question is, can we scale it? Can we scale it safely, repeatably, sustainably, and can we scale it across the organization? And that's really where the real competitive advantage of enterprise AI lies. It's not just proving that AI works, but it's embedding it into systems, into decisions, and operations that are driving companies every day. So in that, there is kind of this hard truth that we're going to anchor today's session in, which is that scaling isn't just about fixing a few things. It's not just tightening your code or refactoring your pipelines. It does actually require lots of different interdependent decisions. And those decisions are across architecture, infrastructure, engineering workflows, organizational design, governance, compliance, capability, and a lot more. So scaling is a discipline in and of itself, I would say. So knowing this is probably a good chance that you're going to come out of today's session with I'd say, a lot more questions than you came in with, and that's a good thing. That's the goal. Knowing what questions to ask to prevent scaling issues is really critical, instead of learning about them when it's too late. So we're going to touch on as much as we can in the 30-ish minutes that we've got today, and we're always happy to do follow-ups with additional questions if needed. So why is scaling so important, and why is it so important to get beyond the POC? Because when we're thinking about AI, when it's done right, and we think about success, we're thinking about a business capability. So how can it accelerate how decisions are made? We think about things like better forecasting, faster risk analysis, more responsive planning. AI can really reshape a customer experience. It can affect hyper-personalized campaigns. It creates intelligent search. It allows us to do dynamic product recommendations, and it can make operations significantly more efficient. So think of automating repetitive tasks, optimizing logistics, identifying issues before they become a problem. And in a lot of the work that we do here at BOI, a lot of the focus of AI is actually on entirely new revenue streams. But none of that can happen unless the AI is scalable. So we think of scaling as kind of this bridge between the promise and the impact. And it's often the time where a lot of organizations will tend to hit the wall. They may know that a use case is valuable. They've probably seen it work in a narrow test. But suddenly when they try and roll it out across teams, geographies, or systems, everything just gets a lot harder. So you start running into these kind of common questions here, which are, can the infrastructure support this at scale? What happens if the model drifts? How do we version this? How do we monitor it? How do we retrain it? What does that handoff look like between business teams, product teams, data teams, engineering teams? And the all-important question of, who's owning this? Who owns this when it's being designed and built? Who's owning it when it's live? And this is often, I think, the scaling gap that we see. The technical pilot is, let's say it's proving that AI is possible. Could be the pilot, could be the POC or an MVP. but the business case actually needs it to be usable. It needs it to be integrated, to be trustworthy, and to be maintainable. So how do we think about closing that gap between the two and making sure that scaling is not just possible, yes, but actually repeatable? So we'll talk a little bit about the journey. Once we've proven that AI is possible, let's say in that POC phase, let's say that we've got a real sense and excitement that there's a real business problem that's worth solving. The question then becomes, what happens next, right? And we think of this as a staged journey. We break it down typically into 4 pretty distinct phases, which are validate, integrate, operationalize, and that final state of scale. We say final state, it's always evolving, but we think of it as kind of the final stage between these 4. So I'll walk through what we mean by each one, and we'll kind of anchor today's session in these 4 stages. So the first one is validate. So usually during or before the POC phase, it's about proving that, hey, the model works, the application leveraging the models work technically, and it's about validating feasibility and business alignment. Is this solving a real problem? Do you have the right data? Is the expected value worth the investment? And this is where you're kind of answering that critical question of, should we do this? Does the upside of this outweigh the investment that we're going to make into scalability? Next up is integrate, which is where we start embedding the AI into real workflows and systems. So it's no longer running in isolation. It's operating alongside other tools, teams, and processes. It might be talking to your CRM, your ERP, your data warehouse, and you're starting to really understand how this thing kind of fits into the day-to-day rhythm of your business. Third is operationalize, which is the transition from kind of we've made it work to this is now part of our system. So you're building the architecture and the tooling that is needed to deploy, to monitor, to retrain, and to govern a model or an application or a combination of both at scale. So you're introducing things like testing, CI/CD pipelines, observability, security layers, and it's where the scaling discipline really kicks in. And we're going to dig in on each of these today. And then finally, the scale phase, not just scale in the sense of make it bigger, but scale in the sense of reusability, standardization, cross-team adoption, and long-term sustainability. And it's really where AI becomes, in our opinion, a capability across the business. It's not just this one-off success story. It's really embedded and it's transformational. So one way to kind of think about these 4 stages that we find helpful is to say, okay, validate is proving that it's possible, integrate is making it useful, operationalize is making it reliable, and scale is making it valuable. And I think if you rush through any of these phases, then your AI initiative tends to start to stall out, and that can be technically, organizationally, or both oftentimes. So we'll use the structure as we go through the session. Validate, integrate, operationalize, and scale kind of as our guide as we touch on many different topics that come together to form the discipline of scaling in AI. So a lot of scalability can be addressed in the POC phase. And I think it's a common misconception that POCs are about proving just a small set of hypotheses and leaving the scaling to later. POCs should be about proving core hypotheses, but they should be designed and built in a way that are supporting and testing scalability later on. So when AI projects do fail, it's usually not due to things like bad modeling. It's usually because the foundation wasn't set during the POC. So a common, or a couple of common red flags actually that we see are here. So if you spot these in your AI projects in your initiative, they are worth addressing immediately because they will eventually come back to bite you at scale. So the first one is having no clear success criteria. And this usually happens when a team is building a POC just to kind of see what's possible, but they never define what success looks like. Is success a certain accuracy score? Is it a business metric improvement? Is it a stakeholder saying, yes, I trust this, I'm excited about this? It can be many different things, but I think if the criteria are vague or they're purely technical, then it becomes impossible to make a go, no-go decision when the POC wraps. And actually even worse, it becomes really easy for stakeholders to retroactively decide, hey, this wasn't good enough, even if the model or the application technically worked. Second one that we see a lot of is misalignment with business strategy. So a lot of the most sophisticated AI models that we've seen never really went anywhere because they weren't solving a priority problem. And maybe it was because it was interesting initially from a data science perspective. Maybe it was fun to build. But if the outcome doesn't map to a business priority, which is something that execs care about, then let's say it's driving growth or efficiency or differentiation, then it is going to struggle to get attention, and it will struggle likely to get funding and adoption. So AI projects that are scaling, that they're almost always tied to strategic initiatives and not just cool ideas, as it were. Third one here is being tech-led without product thinking. This one is super important because a lot of early AI work starts in the hands of either business owners or sometimes in the hands of data scientists or machine learning engineers. And that's really great. But without that product thinking layer between the two, you're going to end up with what we call outputs instead of outcomes. So when you're building in fact, it actually just means that you end up building a model instead of an application. So let's say you're generating predictions as your outcome, but let's say that the interface isn't intuitive and there's just too large of an adoption barrier. You end up optimizing really for more technical metrics instead of considering the user experience and saying, okay, who is the user? What decision are they trying to make? How does this fit into their workflow? What happens after prediction? These are all product questions that need to be asked in this example, and they need to be asked early. So a big difference there between being tech-led and product-led. And then the fourth one here is just around planning beyond the pilot phase. And this is probably the most common red flag. It's when a team is building a POC and then it hits a wall because no one has planned for what comes next. So what infrastructure does this need? Who owns the retraining pipeline? What happens if performance drops? Is it compliant? Is it integrated? If there's no roadmap for what happens after it works, as it were, then the POC just becomes kind of this final point instead of the first step. So as we move forward through some of these next topics, think of this slide as kind of your preliminary caution sign. And if you are working on projects at the moment and any of these red flags show up or they show up in your portfolio of projects, then take a moment to kind of pause and ask, what would it take to scale this and turn this into something real? Because I think the sooner that you address these issues, the easier it will be to scale later. So once you have validated that the AI initiative is solving a real problem and that you've cleared the critical checks that we just talked about in this last slide, the next phase is integration. So it's where the work starts to shift from experimentation to engineering, let's say. And I'd say no matter how powerful the model is, it really can't operate inside the business with real users, real data, real workflows, and generate value if it's not tied into key workflows. And that's a really key mindset shift. The model is not the product. The product is the thing that the business or the customer is interacting with. So it could be a forecasting dashboard, it could be a pricing tool, it could be an interactive interface, it could be a backend API that is powering personalization in real time, let's say. But that product has to work within your existing systems and constraints. So the first integration challenge is workflow fit. And we often ask, okay, what does a model, or when does a model get triggered? Who is using it and how do they receive output? What decisions or actions are taken based on a model's predictions, let's say in this example? Does it need to be embedded into an existing internal tool? Does it need to be exposed via an API? Does it need to be surfaced, let's say, in a UI? So in this kind of experimentation environment from the POC early days, I think a lot of these questions are often ignored. But in production, they really do define the user experience. Second one here is cross-functional alignment just becomes really, really critical. So AI is not just a data science initiative. You do need support from data engineering, software engineering, product operations, and often legal and security. So AI integration, it's a team sport. I think a lot of AI projects struggle at this phase because the handles just aren't clear, or sometimes the incentives aren't aligned between those different teams. And third one here is around integration with core systems. So a lot of the time when we think about AI capabilities that are generating a real competitive advantage that is unique to that company, they usually will have a model that needs to access, let's say, a CRM system if it's personalizing recommendations. They may need to call an ERP system to trigger a supply chain action. They may need to expose output via an API if it's serving a real-time application. And I think this is where a lot of teams often underestimate the effort here. So the technical integration work, as we call it, so things like authentication, rate limiting, error handling, observability, permissions, they're often more complex than actually extracting value out of the model itself. So integration, it's not just about the models, it's about making them useful and reliable and connected to the business. So this phase is really critically important. It's the first time that AI becomes part of a larger system in many of the cases that we see. And if it's not designed to essentially plug into that system effectively, then the POC or the pilot is just not going to survive contact with reality, as it were. So let's say that we have moved past the point of validating that the AI initiative, the product, excuse me, the POC or the pilot, whatever terminology or stage that you're at in the early stages is, let's say that it's viable, and you've begun integrating it into real workflows and real systems. The next stage before you go any further and before you move it into production is making sure that you're making the right fundamental architecture choices. I think one of the most important things to do is just make sure that you're not building what we call a monolith, and that you are being very modular in your approach. And we really drive towards ourselves when we're building AI capabilities, we drive towards building modules. So whether you are building your own model or algorithm, whether you're building an AI application that's leveraging foundation models, or most likely a system that combines both, your architecture, in our opinion, should always be modular from the beginning. Modularity really does give you options, and it lets you swap different components in and out as different needs evolve. So it lets different teams own different pieces. It lets you iterate a lot faster, and it lets you scale much more easily. So a couple of examples of how we think about modularity. Let's say that we are building an insights capability. What we're not going to do is end up hardwiring our foundation model into the app logic. What we are going to do is say, okay, let's have a retrieval module if we're doing RAG. Let's have a prompt engineering module that is defining how inputs are structured. We, a lot of the time, will have a foundation gateway module. So basically, it lets you switch between different foundation LLM providers or versions. We may have a post-processing module that is going to help us format and validate outputs. And then obviously most of what is being built will have some element of a UI layer that should always be decoupled from the backend logic. So if you are working with more custom models, let's say you're building a forecasting capability or a fraud detection model is a pretty good example, then you're going to want to do the same. So you'll want to separate your data prep pipeline. You'll want to make sure that your model inference is isolated. You'll want to run monitoring and logging as independent services. You'll build your CI/CD pipeline around different kind of component level deployments. What we do see as a scenario a lot is, let's say there's the need to upgrade the model. So you want to switch from OpenAI to Claude, or you want to modify your RAG retriever. If your architecture is truly modular, then that's just a one module change. It's not a full system rebuild. But if you've tightly coupled everything, if your logic, your UI, your model, your data sources are all entangled, then every change becomes a pretty stressful rewrite. And that slows down really everything. So this becomes a lot more important actually as you as you scale, to multiple use cases. So if every team is building their own AI stack from scratch, then you're going to end up with chaos, basically. You'll have redundant pipelines, you'll have inconsistent tools, you'll have a lot of duplicated infrastructure. But if your system can plug into shared modules, so think of things like a company-wide retrieval service, or it's another example, maybe a centralized monitoring layer, then you can move much faster with less risk. So modularity, it's not just an architectural principle, but it does allow you to build AI systems that can evolve, that can adapt and scale without essentially collapsing under their own weight. Let's get a little bit more technical on what enterprise-ready AI looks like, and then towards the end, we'll zoom back out. But the first thing that we talk about a lot here in terms of enterprise-ready infrastructure is that it needs to be able to scale automatically. So if you're using a model for something like real-time product recommendations or fraud detection, as we mentioned earlier, then you really can't afford to manually scale servers or hit usage caps. It's just it's not viable. So that's where a lot of really interesting tools like Kubernetes or serverless platforms like AWS Lambda can come in. They let you do what we call elastic scaling, which means that your system can grow and shrink based on demand, essentially without human intervention. And I think that foundation model-based applications in particular, they can experience, let's say, pretty spiky usage, especially when they're exposed to customers or actually even if they're embedded in internal products. So if you don't plan for that kind of elasticity, then you end up either overpaying for idle capacity or for, yeah, I'd say, or even just failing under pressure. And it's usually one or the other with very little in between. Second one here is around CI/CD for your AI components. And for those here that are pretty familiar with traditional software, then you'll know that CI/CD is a pretty mature practice. Code gets tested, it gets validated, it gets pushed automatically to production. But AI systems do require their own kind of CI/CD flows, as it were. So you're not just testing code with AI, you're testing data, you're testing models, you're testing outputs. And you need to be able to push new model versions, prompt templates, retrieval logic, many more with minimal downtime, ideally almost no downtime. So again, a lot of really interesting tools there. Things like MLflow, Jenkins, GitHub Actions is really interesting in terms of machine learning pipelines that can help with this. I don't want to kind of go down the path of the many, many different tools out there too much for today. But the point is that updates, they do need to be safe. They need to be fast. They need to be repeatable, just like in modern software engineering. And if folks have tools or platforms that they have used that they really like, definitely feel free to share them in the chat with the rest of the community as well. And third point here, just to wrap this up, is AI systems, they do drift. So that means that data changes, behavior changes, regulation changes, and you absolutely cannot rely on a model that was trained once to serve you forever. So enterprise-grade AI systems, they need to support things like automated retraining pipelines. So that means basically they're triggering when certain thresholds are hit. So if accuracy drops, for example. You also want to think about rollback mechanisms. So if a new model version performs really poorly in production, you need to be able to revert back immediately to your previous setup or your backup setup. And that's really important, actually, especially for high-risk use cases. So we think of high risk as anything that is customer facing, anything that is regulation sensitive, anything that is decision critical. Without these kind of core drift capabilities, then your drift detection capabilities, I should say, then your AI project is going to work in theory, but likely fail in the real world. So you don't want to be having to email your engineering team or your external partner to manually redeploy a model. You don't want to realize that your LLM-based application is failing because a prompt change wasn't version controlled. That's not enterprise ready. So this is the shift we're emphasizing with this, is around AI systems are not experiments anymore. They're products. And like any product, you need robust ops to make sure that they're stable, secure, maintainable, and resilient. So let's talk about what sits underneath every scalable AI product, which is the data infrastructure. And this is really one that I think could be 10 webinars in of itself, but I'll touch on, I think, what are some of the important points when we think about scaling, because in early stage POCs, I think it's pretty common, and actually I would say acceptable and encouraged to work with offline data sets. So you'll see a team pulling historical data from a CSV or maybe even a snapshot from a warehouse, and that's fine for proving the core concept. But when you're scaling AI in production, especially across multiple teams or systems, and that approach does start to break down. The reason being that your AI system can't just work once, right? It needs to work every time, in real time and under real conditions. So you need a data architecture that's robust, responsive, and is ultimately integrated into your broader operational systems. And this is where we start thinking about things like streaming versus batch. So if your use case involves real-time decision-making, let's say the fraud detection example from earlier, then you need a streaming architecture. And that's typically built on platforms like Kafka or Kinesis. And they basically handle really high throughput and low latency ingestion. But an alternative example is, let's say you're working with use cases like quarterly forecasting or churn prediction, then batch data totally makes sense. And you can use tools like Spark that are pretty great for this. But the key is really to choosing the processing model based on how fast your model needs to act. So whether it's real time or batch, the data quality is kind of the make or break factor. So as we say, garbage in, garbage out. So at scale, your pipeline really needs to make sure that it includes things like automated data validation, so checking for nulls, anomalies, schema mismatches, things like that, before the data even touches your model. Next up is lineage. Again, very relevant if you're in a regulated industry, especially. You need to be able to trace where your data came from. So what happened to it along the way, how it was used in a decision. It's critical not just for trust, but also for debugging, auditing, continuous improvement, etc. And then another important one here is around ETL versus ELT. And historically, we've used ETL as an industry, so extract, transform, load, because we had to shape the data before storing it. But today, I think with cloud scale storage and just processing power in general, we do see a much bigger shift to ELT, which is extracting and loading raw data first, and then transforming it later, much closer to the point of use. So it means that your raw inputs are preserved, they're auditable, you gain a lot more flexibility in how data is consumed across teams and models. So the bottom line is that when AI moves from pilot to production, your data infrastructure kind of becomes a product in itself. It needs reliability, it needs observability, it needs adaptability, just like the AI models and applications that it supports. Again, this is one that this next slide could be a webinar in and of itself, but we'll chat a little bit about what we call the invisible ceilings that you start hitting as AI systems grow. So it's those technical bottlenecks that emerge when you go from experimentation to scale. And the good news is that they're pretty common. You're not alone. They are often solvable with the right architectural choices and operational maturity. But 4 of them that we see as being potentially inevitable, so you need to know that they're coming and what to do. Context and token limits, obviously in foundation models. So a lot of foundation models have actually fixed context windows, which a lot of people aren't aware that those are fixed. It's the max amount of text or tokens that they can process at once. So when you hit that ceiling, you are going to get failures, or worse, you're going to get performance degradation that you actually don't even notice until it's too late often. So to solve this, many different techniques. Again, this could be a whole webinar in of itself, but some of the most common are obviously using RAG, chunking and ranking logic, which is breaking content into different units and scoring them based on similarity or relevance. Pre-processing compression, so using what we call extractive summarization or entity filtering to reduce prompt size before injection. And long-term, we're going to really monitor token usage trends over time so that you can anticipate when you start to reach those ceilings. Second one is around real-time latency challenges. So as soon as your AI system becomes part of a live user-facing workflow, then it needs to be fast. And foundation models, especially large ones, are not so well designed for that kind of sub-second latency out of the box. Lots of different solves for this, again, in very different scenarios. You can use smaller models. You can pre-compute parts of the response pipeline if possible. You can optimize input structure. If you're building with foundation models like an OpenAI or Anthropic, then you can experiment with parallelizing calls across retrieval and response. So different ways there that your team or your external partner will solve for that. Third one here is around retraining frequency. We touched on this a little bit earlier with drift detection, but as data evolves and user behavior changes, your AI systems can slowly start to become stale or potentially biased, actually, in some cases. So you want to think of retraining as proactive instead of reactive. So we talked earlier about drift detection. You can do things like scheduling retraining pipelines, maintaining train test splits over time. You can do things like prompt regression testing every time the foundation model changes or inputs are updated. Lots of different ways to think about how you can automate that resilience in. And then last one here that your DevOps team likely think about a lot, but version sprawl and traceability. Again, when you're moving fast, it's common to kind of fork your models or your inputs per market or use case or POC, and then you can pretty quickly be left with a bit of a mess, as it were. So you have 10 different model versions, you have unclear ownership, you don't have audit trails. A lot of really interesting ways to solve this. You can use model registries, you can use version control for inputs, you can use inference logs that are storing inputs, storing model versions, inputs, outputs for each request, etc. Again, lots of different techniques actually for each of these, but I think it's important to have a sense of the four and just make sure that you are asking the right questions, because it's not just about traceability in terms of this last one, for example. It's about how can we debug, how can we compare performance, and how can we ultimately build trust in the AI stack. Everything that we have here in terms of these four bottleneck areas are about how do we solve these to make sure that we're building trust in our system. I want to just touch on governance and compliance. I think often it's seen as red tape or slow down, but in reality, it's what allows you to move a lot faster, more safely. So especially when AI is touching customer data or financial decisions or regulated environments, it's a really important part of the scaling process. So we think of 4 pillars of governance that need to be in place before you scale. The first one being data privacy by design. So starting with the simple question of, does the system handle PII? Does this handle sensitive data? And if the answer is yes, and it usually is, then you need to build in privacy controls from day one. Don't just assume that your foundation model provider is GDPR or HIPAA compliant on your behalf. You absolutely do still own the risk in most cases. Second, we've touched on this already, is monitoring for drift and bias. So as models learn and the world changes around them, they can drift, as we said. So you want to think about classification. And if you're seeing more false positives or negatives, then you need to start monitoring input drift and prediction drift. And when it comes to bias really can reemerge at any point, especially in foundation models where your control over the training data is essentially non-existent in most cases, unless you're using RAG or fine-tuning. The solution, again, is testing prompts, testing predictions across user segments, implementing guardrails, thinking about bias detection metrics so that you are focused not just on accuracy, but also on fairness and bias. Third one here is role-based access control. Essentially, not everyone should be able to access every model, dataset, or prompt. And then the last one is around explainability and audit trails. So whether you're using your own model or a third-party foundation model, AI explainability is really critical for trust. So every decision doesn't have to be fully transparent, but some models are black boxes, which means you need to be able to explain what model or version was used, what inputs were provided, what outputs were returned, and what scoring or filters were applied. And again, foundation models do complicate this because the model internals aren't yours, but you are still responsible for the output. We're going to touch here on the last point in this section around security infrastructure. AI systems do introduce new security challenges that traditional software doesn't fully account for. So if you're scaling AI across the business, then security, it's not optional, it really is urgent. So for us, we've got a couple of core best practices. I think everyone should have these best practices if you don't already, which is that encryption is required at rest and in transit to protect against things like deception, leaks, unauthorized access. Identity and access management and logs, super important, making sure that every user, service, or process that is touching the system has clearly defined identity and access policies, making sure that everything is logged. Red teaming and adversarial testing, a little bit more advanced, but oftentimes it's not just enough to build a system and hope it's secure. You do need to test it like an attacker would. So Risks don't just impact the user, they are impacting your brand, your reputation, your trustworthiness, in some cases, legal liability. So some of these more complex approaches can be really helpful. And then last one here, I do want to reiterate that the foundation model provider, whether it's OpenAI, Anthropic, Google, or anyone else, is not your firewall. It's tempting to assume that they handle the security. And yes, they often do have robust protections on their end, but the app is still your responsibility. That capability, that application, that tool, you own the inputs that you're sending, the way that responses are handled. The same principles apply, right? And then as we think about moving from a project to a platform, I think the early stages in AI adoption tend to be a little fragmented. So the customer team is building a tool, let's say the insights team is running a language model, the ops team might be trying out something else. Each one is kind of building for its own data, its own connectors, its own logic, its own monitoring. And that's okay at scale, but it does create a duplicated efforts over time. It creates inconsistent quality. It can create really fragile systems. So we do a lot of work here on this shift to shared infrastructure. And at scale, I think the winners that build once and reuse everywhere will really, I think, get an advantage that is tough to catch up with. So that means basically creating a core platform layer that gives you the foundational capabilities for all AI product teams. And that foundational layer or that platform, it could include a data access layer, an embedding service, a input management service, a monitoring observability platform, things like that. Model deployment and orchestration is another really common one as well. But those are platforms that are usable by all teams that are not just tied to a single use case. So they're modular. They're reusable components that every team can plug into. And it just means that your AI capability as an enterprise is running smarter, and it's driven by reuse, reliability, and reach as well. We're going to do a separate webinar on organizational readiness, because I think there's a lot in here, but I think a lot of even the most advanced AI systems will stall out if your team's roles and responsibilities are not set up to support them. So starting with a single team or an external partner is very common. And I think an interesting solution that we've seen work really well is kind of this hub and spoke approach, where you have a central AI enablement team, and then you have embedded AI capable roles within different business units. And the work of the actual product development tends to happen in the business units where the product lives, but that product ownership is really, really important. So if AI stays in a technical silo, it's not going to scale. You need product owners inside the business that understand the workflows, the users, and the metrics. And those are the folks that are making sure that AI is designed to absorb and kind of extend the capabilities across different teams. So we see a shift from this idea of AI specialists to AI augmented teams. Almost wrapping here, but monitoring, it's not a luxury. It's a non-negotiable part of scaling AI responsibly. So you want to think of monitoring as your AI control tower. And you always want to build with a long-term strategy in mind. If you want AI to become a durable source of advantage, then you need a multi-year strategy that is continuously investing in tools, platforms, talent, and upskilling, which means responsible governance and cross-functional operating models. So bringing us to the end here, I think if there's one thing that I hope you take away from a lot of what we've discussed today, again, we went fairly broad. There's a lot that goes into scalability. But scaling AI really is the real work. It's not just a flashy demo or a successful pilot. It's that deep, thoughtful, often invisible work in building systems, processes, and the culture around AI so that it can thrive. So if you are at a stage where you're experimenting with AI and wondering what happens next in your enterprise, then we're always happy to chat. We specialize in turning those early POCs into enterprise-grade capabilities. So thank you, everyone, for joining. We covered a lot today. Happy to take any questions on email and do follow-ups, and looking forward to hearing what you all are building next.